This video is going to be talking about the perimeter and area of parallelograms and triangles. Here we're going to first talk about the area of a parallelogram. Any side of a parallelogram can be called a base. The height of a parallelogram is going to be perpendicular, meaning that, remember, this means 90 degrees. It's going to be the perpendicular distance between two bases. As you can see right here, here's h, your height. It's perpendicular, and we'll call these the bases. Okay, and here is your formula: base times height. That's it. Now, in some cases, you'll have your base and your height. Other cases, you're going to have to find. You're going to have to use Pythagorean theorem, special right triangles, or trigonometry to find missing sides. First, let's go ahead and start off. We want the perimeter and the area of all of these. We're going to round to the nearest tenth. Now, to find your perimeter, for your perimeter, we need to add up all sides. Well, here we should be able to note that this side is going to be 18 total. And as we learned with parallelograms, opposite sides are congruent, so this right here will be 18 as well. Now, we do not have the other two sides. So what we're going to do is we're going to pull this triangle to the side over here, and we're going to use our Pythagorean theorem to solve. Okay, so here we have this triangle. I'm just retracing it. We know that this is 8. We know that this is 16. We need to find C. So here we'll use C squared equals A squared plus B squared, which will be your 8 squared, plus 16 squared. Square the two numbers, you're going to get 64 plus 256. We're still bringing that C squared down. We're going to add these to get 320. And I know that in our classes we have learned when you take the square root, we want to simplify the radical, but in this case, because we are having to round to the nearest tenth, we'll just go ahead and round to the nearest tenth. We're going to wind up that this side is approximately going to be 17.9 rounded to the nearest tenth. It's 17.88 something majiggy. So over here, we'll go ahead and say this is 17.9. So to find our perimeter, we can either add all four sides up, or since two pairs of sides are congruent, we can simply say 2 times the 18, so there are two of them, plus 2 times the 17.9. The 2 times 18 is going to give us 36. 2 times 17.9 will give us 35.8. We simply add these together. Our perimeter is going to wind up being 71.8, and this is in feet, so we will have simply feet. All right, so for our area, remembering that area, as it says at the top, is base times height, little b, little h. And so we're going to take the base, which our base was down here at 18, times the height right here of 16. Area is in feet squared or units squared. When we multiply the two of these, we get 288 feet squared because we are now going two-dimensional. Number 2. We are going to have to, again, figure out what we have here. Now, we also do need to notice that we have all four congruent sides. We are going to wind up with a rhombus here. All right, so we know that all four are going to be 24, so we can go ahead and label all of those. So our perimeter is going to be pretty easy. Okay, when we do the perimeter, but I'm going to kind of leave myself some room. I'm going to have to do some work over here. When we do the perimeter of something that has four congruent sides, we can do 24 plus 24 plus, or we know it's four sides times that 24. Your perimeter is simply going to end up being 96 inches. Now, for our area, we need base times height. We are missing the height here. Okay, so we are missing height. So again, we're going to pull this to the side, and we're going to take a look at just the triangle. Now, with this, because we have 60 degrees right here, in parallelograms, opposite angles are congruent. So here, this would be 60. So you have a 60-degree angle here and 90. You can use 30, 60, 90 To complete this, and I'll show you that real quick, you have your 30, 60, 90. Remembering that across from the 30 is A. Across from the 60 is your A square root of 3. Didn't leave myself a lot of room there. Across from your 90 is 2A. So right now we're looking for this A square root of 3. Well, we know that this is 24, as it says right here. Okay? So A is going to equal 12. Half of that, we just divide it by 2. Then we substitute in for A and we get 12 square root of 3. Okay? So your height would end up being 12 square root of 3. A lot of people prefer to do the trigonometry. If we again take a look at this triangle here, if we use trig, we're going to be looking for side over here, or H. It's getting really, really messy. Sorry about that. So when we're taking a look at the angle we have, this is our reference angle. We're going to be looking for H, so we're looking for our opposite and our hypotenuse. So this is going to be our sine. Opposite is opposite over hypotenuse. So we take the sine of the angle that we have, 60. We have our opposite, which the opposite of 60 was the the height, what we don't know, over the hypotenuse of 24. When we have this situation here, we've learned that we just cross multiply. So your height is going to end up equaling the 24 times the sine of 60. So your height will be approximately 20 to the nearest tenth, 20.8. And you're going to find that out if you put 12 square root of 3 in the calculator as well. So let's take a look at the area. Area being base times height. We're going to take the base of 24 times the height of 20.8. These we find the area will come out to 499.2. And this is in inches, so we are in area. We have two-dimensional, so an exponent of 2. Now, as you round it to anything else, like the nearest thousandth, something like that, you're going to come up with something a little bit different. But we're just keeping it, rounding everything to the nearest tenth. All right, next one, take a breather, because this one is going to be a lot more simple than the other. We have a square. How do I know? All 4 sides are congruent. All 4 angles are 90 degrees. So simple and easy with our perimeter. I didn't write this formula earlier, but we do 4 times the side, and the side length is 1.6. So we do 4 times 1.6. Your perimeter ends up coming out to 6.4 centimeters. Nice, simple, and easy. When we take a look at the area, we're still doing base times height, but with a square, you can do either your base times height, or you can just do the side squared. Either one. Okay, because it's going to end up being the same thing, 1.6 times 1.6. And so your area rounded to the nearest tenth will end up being 2.6, and we're in centimeters squared with area. Now that we look at area of triangle's formula is pretty simple, but I'm going to warn you right now, we have a lot of work to do on all these problems. We're going to have a lot of Pythagorean theorems. Let's just jump straight into this part. We have the area of a triangle is 1/2 of the product of the base and its corresponding height. And like a parallelogram, the base can be any side, and the height is the length of an altitude. All right, so again, your altitude, your height, perpendicular. So now we're going to take that base times height and we're going to divide by 2. We're going to find the perimeter and area again. We're going to round everything to the nearest tenth. We're going to have a lot of Pythagorean theorem here, so let's go ahead and get started to make this as short as possible. All right, first things first, we need to find the perimeter. Well, to find our perimeter, we've got a side here, we've got a side here, but we are missing this side right here. So the first thing that we're going to do is we are going to find this side by using this right triangle. A squared plus, actually first, sorry, we do have to find that height first. But these are going to be the 2 that we're going to find, okay? So let's go ahead and find our height first so that we can find this side. So we're going to have our h for our height squared, because it's one of our legs, plus the other leg, 3 squared, equals 5 squared. And some of you may know your triples. You already know what it is, but we're going to go through very, very quickly. Height squared plus 9 equals 25, squaring them. Then you're going to subtract that 9 from both sides. You're going to get h squared is equal to 16. Last step in Pythagorean theorem, square root, your height is going to equal 4. Okay? So now that we have that, we have 13 and we have 4 for our 2 legs. We can find this last side, which is going to be c. So we take our 4 squared plus the other leg, 15 squared, all equal to c squared, what we're missing. We square these out. We've got 16 plus 15 squared is 225, all equal to c squared. Squared, now we're going to add. We're going to wind up with 241 is equal to c squared. Last step in Pythagorean theorem, take the square root. Your c rounded to the nearest tenth is going to come out to approximately 15.5. So, a lot of work. I told you there's even more Pythagorean theorem coming along. Let's go ahead and find our perimeter. Our perimeter, we're just going to add all 3 sides up. So, here we need to remember this dashed line is not part of our triangle, okay? The base right here is 15, so we have our 15, plus the height of 4 that we found, plus that the hypotenuse right here, 15.5 that we found. We add all of these together, and we're going to wind up with 34.5. We are in centimeters. Area. With our area, we remember that we want base times height divided by 2. So focusing only on, again, not on the dashed line, we have our base of 15 times our height that we found was 4, all divided by 2. And what you can do when you're multiplying 2 numbers, if you can divide something out right here, like this 4 into the 2, you can go ahead and do that if you'd like to. And say, okay, well, 4 divided by 2 is 2. So now you just have to do 15 times 2. Or, guys, just do 15 times 4 divided by 2. Just do it the normal way. And this is going to come out to 30. And we're at centimeters. Area is 2-dimensional, so 2 exponent. Centimeters squared. Next, yes, we're going to have to use Pythagorean theorem, ladies and gentlemen. All right. First of all, I want you guys to see that this is a altitude. It's 90 degrees. We learned with altitude and a triangle can be drawn outside. So we do have our height, and we do have our base, so we can find our area. But we're missing this side to find perimeter. So let's go find that missing side, which is the hypotenuse of this non-existent triangle here, and so we can get our perimeter. So here, we'll go ahead and we're looking for, we've got our legs, we've got 8 squared, plus the height over here, 16 squared, all equal to our missing side. Didn't leave myself room here. 64 is 8 squared. 16 squared is 256. We add those together, we get 320, equal to c squared. Last step, Pythagorean theorem, square root, rounded to the nearest tenth, we're going to have approximately 17.9. So here we have 17.9. We now have all 3 sides, and we can go find our perimeter. Add all 3 sides up together, the 22 plus the 34 plus our 17.9. In feet, our perimeter is equal to 73.9 feet. Area, again, base times height divided by 2. This time I won't do what I did in the last one. We'll just straight up do the base. Remember, it's right here. Just the 22. The 8 is not part of the triangle. Okay, we've got our 22 times our height, which that's why this triangle is drawn out here. Okay, our height is 16 divided by 2. When we do the multiplication and divide, we're going to wind up with the area being 176. We're in feet. Area is squared. In a second, you're going to see a jump in the screen because I do have to pause the video and resume later because I'm out of time before class. So if you see that little jump, you understand. Okay, so for this next example, again, just find a perimeter. Well, right now, to find perimeter, we only have this one side here. What we need to notice first off is that we do have two congruent sides, giving us an isosceles triangle. Meaning if we could find one, we've got the other. Let's Pythagorean theorem it again. Okay, so we're going to take this triangle right here, this right triangle. Here's our altitude drawn, 90 degrees. Okay, giving us our right triangle. We pull this guy to the side. Okay, really tiny here. This is 28. This down here is 20. I'm sorry, this one. Let's rewind real quick. The whole base is 24. So we need to understand, we need to remember in isosceles triangle, when you have the altitude drawn, it's going to bisect. It's also going to be a perpendicular bisector, creating two congruent sections down here, giving you 12 and 12 each. So this down here will be 12, and we're going to be looking for C. Okay, so with our a squared plus b squared equals c squared, we'll have our 12 squared plus the 28 squared equals c squared. We square 12, we get 144. We square 28, we're going to get, 784. All equal to c squared. We add these two together, we're going to get 928 equals c squared. Again, last step in Pythagorean theorem, square root. Rounded to the nearest tenth, c is going to be approximately 30.5. So this is going to be both these sides, 30.5, and turn it as 30.5. So now we have all three sides of our triangle. We can find our perimeter. Now we can do 30.5 plus 30.5 plus, again, the whole base is 24. Or since we have two sides are exactly the same, we can do 2 times 30.5. Because there we've covered both these sides, just like in a square. We can just multiply it by 4. But we need to make sure that we add this 24 down here. When we complete all of this into our calculator, our perimeter is going to come out to approximately 85. Our units are meters, and it is perimeter, one-dimensional. Area. Our area, we have base times height divided by 2. Our base right here as 24. Our height right here as 28. All divided by 2. If you'd like to cancel one of these out, cancel the 2 with one of these, you can, or you can just do all the multiplication all the way through. And if we do cancel this out, this will now be 12 times 28. No 2 exists anymore. Just showing you that again. Your area is going to end up being 336 meters. Area is 2-dimensional, so it is squared. All right, our last problem is going to be a word problem. We're going to have to do some working backwards on here. Let's start this off little by little, okay? First things first, the base of a triangle is 4 times its height. 4 times the height means 4 times h, whatever h is. So this is the base. So what we're going to start off with is we're going to go ahead and say, okay, a base, b, is 4 times the height. 4 times h. We don't know the height, okay? So now, since we can't find the base, because here we are going to be finding both the base and the height, okay? Can't find that yet. But what we do have is that your area is 242 squared millimeters. So our area, remembering, area formula is base times height divided by 2. Let's take a look at what's happening here. We can plug in for the base. What we can plug in for the base right here is right here, this 4h. So we can plug in 4 times h. Now we have to bring that h down, and this can get confusing. We replace base with what base is, and then now we need to bring down that h for the height and divide by 2. Okay? We only have one variable. Sorry, this looks like a z. We only have one variable, so that's fine. Now, a couple options. You can go ahead and you can cancel this out, divide the 4 by the 2. I'm going to go ahead and do that. So now I have 2h times h, okay? We have the 2h times h. The denominator's gone because I divided this. And so now when we take these and we know that our area, which is 200, which I probably should have put up here, area is 242. 242, our area, is equal to, well, when we take this, we end up with 2h times h. It's just like saying x times x. We have an x squared. So here we're going to have 2h squared. Last step with exponents is always getting rid of that exponent. So we need to get rid of the 2 first. So we're going to divide both sides by the 2. And we're going to have h squared equals it's going to equal 121. Last step, square root. Here, h is going to equal 11. Now, this is your height. For the base, now that we have the height, we now, and a lot of arrows, need to go over here and substitute in for h. So your base is now 4 times the height of 11. So your base ends up equaling 44. And these are in millimeters. We didn't label it. I know it's a lot of work, but that Pythagorean theorem is going to be there. So keep an eye out for that. Please search videos on area of triangles, area of parallelograms, or ask your teacher for any questions.